Okay, this is problem one of the end of class assignment, the exit ticket assignment. A drug company currently sells a prescription pain reliever that has been shown to be effective at lowering arthritis pain. However, since the drug also causes stomach irritation in some patients, the company has created a new formulation that it hopes will reduce that side effect. All right, so that's probably important to see if the new formula reduces the occurrences of stomach irritation for users of the pain reliever. The company conducted a small preliminary study to compare the new formulation with the current pain reliever. In the preliminary study, 100 subjects with arthritis pain, 50 were randomly assigned to take the current pain reliever, and 50 were randomly assigned to take the new formulation. So we have 50 getting the current and 50 getting the new. Patient responses at the end of the study were summarized in the table below. So looking at the table, under the current medication, we had 21 who had stomach irritation, and of those 50, we had 29 taking the current who did not have. So this is our 50 who are taking the current. Here we have 50 taking the new formulation, and 17 had stomach irritation, and 33 did not have stomach irritation. So it looks like we have 4 less people having stomach irritation here, because it's 21 minus 17. There's about 4 less people having stomach irritation. Then it says, do the data from the preliminary study indicate at the 10% level, so we have our alpha level right here, of significance that the new formulation helps to reduce the proportion of patients with stomach irritation. So here we're talking about, this tells us we're focusing on stomach irritation, all right, compared to the current pain reliever. The conditions for inference have been met and checked. And I wanted to address that, the conditions of inferences having been met and checked real quickly. If they tell you it's been met and checked, that means you don't have to do it. And always be cautious. If you provide extra information and it happens to be wrong, they will deduct points. So if they tell you it's been checked and verified, you probably don't want to check and verify it yourself, because if you make a mistake, they will count it wrong. Now, if you do it correctly, it's not a problem. Okay, so go back to this part right here that I highlighted in yellow. They want to focus on those with stomach irritation. Now, you were not required to do it this way, and there are multiple ways to approach this problem, but they really indicated that they wanted to focus on those who had stomach irritation. So basically the 21 out of 50 and the 17 out of 50. And I'm going to make this X1 and this N1, and this will be my X2 and my N2 in order to create my P hats. So I'm going to just start off with P1 equals P2, and P1 is greater than P2. And it's like, well, that didn't help because we don't have definitions. So let's put the definitions to them. And if you want to do the definition before you write your null and alternative, that's fine. So P1 equals the true population proportion of patients with stomach irritation using the current. All right, so there we go. P1 is the current, so that's what, and that's consistent with my X1 and N1. P2, the true population of patients with stomach irritation using the new. And once again, this was P2, and that's consistent with my X2 and N2. Now, we're saying that supposedly we had more people with the, or hopefully we had more people with the current, and it reduced as we went to the new. So this is why I knew that this was going to be a less than. The current was going to have more stomach irritation than the new. Could you have flipped it? Yes, you could have, but it just depends on how you set things up and defined it. So my current had more stomach irritation than my new. And once again, I focused on stomach irritation because that's what they said here. So P1 or P hat 1, X1 over N1. Well, that's just that X1 and N1 that I referred to here. 21 over 50 equaling 0.42. P hat 2 is X2 over N2 is 17 over 50 equals 0.34. Now, they told us we were key phrase in here as they're testing at the 10% level. So this lets me know I'm going to be using a hypothesis test. All right, so if I'm having a hypothesis test, please remember it's always going to be a Z if we're working with proportions. If we're working with proportions, it's always going to be a Z test. All right, so here's my formula: P hat 1 minus P hat 2, my current medication minus my new medication. But then I have to remember that I can't use P hat 1 and P hat 2 here. I have to use the combined because we have to pool with proportions. And please don't forget, please remember, we only pool with proportions. We don't pool with means. Since we only pool with proportions, this is going to be P hat combined. So we're actually summing X1 and X2 and N1 and N2 combined together right here. So 21 plus 17 gives us 38 people had stomach irritation out of the total of 100. All right. Now, could we have used this? Yes, we could have 38 out of 100, but this is where it came from, and you have to show this formula, and you have to show this work, and then you need to give this because you're going to use it here at 0.38. Now, here you can put 0.38 or 1 minus 0.38 on here, or you can use the 0.62. That's up to you. Notice these just happen to be the same. They wouldn't have, they're not necessarily the same. It's just in our case, N1 and N2 as defined as 50 were the same. But if this had been 50 and this had been 75, there would have been no issue at that point. So then we need to go plug this into the calculator, plug the information that we have. We're going to go stat, arrow over to test, and we're going to be looking at a 2 proportion Z test, which is number 6. All right. And the first thing it asked for is X1. Well, X1 I said was going to be 21 and N1 was 50. Then we have X2, which we said would be 17, and N2, which is 50. And what we showed in our alternative hypothesis was a greater than symbol because our pain was going to be reduced from the current to the new. And we get a bunch of values. Now we need to be very, very careful with this. This is our Z statistic. The very first one is our Z statistic. And that's what we recorded right here, 0.8241. This next thing, the next value is not a P hat. That is our actual P value. All right, 0.2049. And notice on my calculator, it doesn't have a hat, so that helps. Then we have P hat 1 is 0.42, P hat 2 is 0.34, which is exactly what we showed. And then we also have our P pooled or P combined. This is the one that gets people messed up because it doesn't have any labels on it, okay? So please notice it's Z then P. So this is gonna be your Z statistic and your P value. Well, that's a fairly high P value at 0.2049. So that's about 20%. Well, that's gonna be greater than our alpha level of 10. And once again, I know y'all are awesome, smart people, but I like to make these the same length. And 2049 is obviously larger than 1000. So it's greater than, so we failed to reject. What are we failing to reject? The null. So please include that. So our sentence, our p-value is 0.2049 and we failed to reject the null. There is not sufficient evidence at alpha equal 0.1 to suggest that the true population proportion of patients with stomach irritation using the current drug is greater than that of those using the new drug. So in other words, in simplified terms, relative to the current drug, we cannot say that the new drug decreases the proportion of people developing stomach irritation. All right. Obviously, we look at this and go, you know what? 34%, that's fewer than 42%. Or we can sit there and go, you know what? 17 out of 50, that's a definite, that's a smaller fraction than 21 out of 50. So there was a reduction, but it's not enough to be considered statistically significant. So we cannot say that the new drug decreases the proportion of people. Although we have some evidence, we don't have enough to say that there is enough. All right. So part D, and part B, they included a whole lot in this question. So based on your conclusion in part A, which type of error, type 1 or type 2, is possible? Well, what we did in part 1 or part A is we failed to reject. Well, if we failed to reject, the only type of error we can make is a type 2. So I'm going to address this part first. So I'm going to state what I did. We failed to reject the null. And there's my little clue, failed to, so type 2. The only type of error that we could have committed is a type 2 error. Yay, I answered that part. Then it says, describe the consequences of each error in the context of the study. Well, because it says each, that means I have to address not only the type 2, but I have to address the type 1. I know we could not have committed a type 1 because we failed to reject, but we still have to address both in order to receive full credit. So I started off with the type 2 only because that's the one that I just addressed here. In this case, a type 2 error would be believing the current drug and new drug have similar rates of stomach irritation, which is what we believed, when in fact a new drug has a lower rate. In other words, our belief was wrong when the new drug had a lower rate. The consequence is that the pharmaceutical company would not develop a new drug that would help decrease the rate of stomach irritation among arthritis patients. They wouldn't make the new drug because there's no difference. The type 1 error would be rejecting a true null. So I gave my definition of a type 1 error. In this case, it would mean that we would believe that the new drug decreased stomach irritation when it didn't. So we believe that the new drug worked, but it didn't. The consequence is that the company would spend money developing and marketing a new drug that was not any better than the old one. All right. That part had a whole lot of section to it. If you had 2 of the 3 parts, you got partial credit. Okay. But it's real, I mean, really to get full credit, which I think all of you could have done, you needed to make sure you address the first part was what type of error. And by the way, just saying I could have committed a type 2 error gets you no credit because you had a 50-50 chance at guessing. So you have to say why it could have been a type 2. So make sure you always address why it was a type 2 or why it could have been a type 2 error. And the reasons why it could have been is because we failed to reject. So therefore, the only type that we could have committed is a type 2. Part C, extraordinarily challenging part of the question. And I will tell you that was missed by almost everybody who ever taken this test because it had not been presented before this particular year. If you got to part C and you missed it and you had everything else right on the problem, you would have gotten 3 out of 4 points, which is a 75. And normally in life, we're not happy with a 75, but please remember that on the AP stats exam, a 75 means that if you make a 75% on the entire exam, you actually get a 5 on the exam, highest score. If you made a partial up here and missed this, then you would have gotten half credit, 2 out of 4. 2 out of 4 is a 50, which is not a very good score in class. Matter of fact, you failed. But 2 out of 4 on the AP statistics exam is a 50%, which is a 3. Matter of fact, it's right in the middle of the 3. It's not a low 3 or high 3. It's a middle of a 3. So it's actually a passing score. So it's not the end of the world. I just kind of wanted to give you some encouragement on this. So part C, After the preliminary study, one of the researchers of the company suggested that the procedure described above would have more statistical power if the sample size was increased. In other words, and that is true, increasing sample size will increase power. And recommended that a simulation study be conducted to investigate that more completely. For the purposes of the simulation, the researcher assumed that 40% of the patients on the current pain reliever would have stomach irritation, and then only 30% of the patients on the new formulation will have stomach irritation. So right here, they're saying there's a difference. This was the current meds, 40% had stomach irritation, 30% with the new meds. So obviously there is a difference, so we should be rejecting. All right. Further, the total sample size will now be 200, with 100 subjects randomly assigned to each treatment. 100 trials on the simulation were conducted. So we did this simulation, and we did it 100 times. A p-value was calculated for each trial based on the procedure, significance level, and hypothesis test, and used in Part A. So remember, we used a significance level in Part A of 0.10. A histogram of the p-values is given below. So here we have a list of the p-values, and we continue to read further down. Use the information in the histogram to estimate the power of the test if the test is performed at the 0.10 level, which is what they told us in Part A. This is our alpha level is 0.10. All right. Indicate how you obtained your estimate. If you just glance at things, and I recognize this is really crowded, you might miss this. The x-axis right here is labeled p-value. So here's a list of my p-values. Well, when do I reject? I reject if my p-value is less than alpha. Well, my alpha is 0.10. So if I have a p-value less than 0.10, I reject. Well, guess what? These are p-values that are less than 0.10. So if I combine these two together, those two bars together, then I'm going to be rejecting. Well, it's difficult to read these bars exactly. And so if you were close, that was good enough. So my p-value right here, 45%, I had 45 or about 45 on this one, and about, 15 right here. So 45 plus 15 equaled 60. Now, if you ranged anywhere from as low as 55 to as high as 65, showing your work, showing the math here, you receive full credit. Also, you probably want to circle the bars that you use, because that lets people know that, hey, that's where they got those values from. So they're asking me about power. Whenever someone asks me something that has a definition, I tell them, hey, I'm smart. I know my definition. And my definition is power of the test is rejecting a false null, correctly rejecting a false null. This is the definition, doesn't really give me credit, but it'll help me with my explanation. Well, so that tells me I know what power is, and I need to know when I rejected, because we're talking about p-values. So when do I reject? So I'm going to tell them I'm smart. I know when I reject. We only reject the null when our p-value is less than alpha. And it's like, well, yeah, that was duh. That is when we reject. In this case, our p-value must be less than 0.10. Why? Because that's alpha. All right. So the graph of the simulation indicates that our p-value is less than alpha or less than 0.10, because this is our alpha, 60 times. I got, here's where I show my complex math, 45 plus 15. Now, if you ended up with 55 to 65, you get full credit. So 60 out of the 100 trials, or 60%, rejected the null. In this case, the power of the test is 0.60, the 60 out of 100. We will correctly reject a null if the two medicines have equal currents This is the null that they were equal, P1 equal P2, in favor of the alternative. We'll correctly reject this, so this is gone. We now believe that the current has more stomach irritation than the new. Okay, and that is part one. And like I said, if you didn't, or this is question one, if you didn't get all of it right, and you got, if you only got part A right, if this is the only part you got right, you'd receive 2 points out of 4, and that would put you in as a solid 3. If you got part B correct, fully correct, and got C wrong, that would be 3 out of the 4 points, which is a 75. If you got this partially correct, then it kind of becomes a holistic thing, and it's hard for me to tell whether or not it's going to be a 2 out of 4 or a 3 out of 4. One other thing to point out, and every year I'll put this on a test, and someone, or that I've put this on the test, we know that power equals 1 minus beta. Beta was a failure to reject, and someone will actually try to add these up and subtract from 1. And guess what? That's absolutely correct. This is probably easier looking at the 2 bars, because that's a tough thing to estimate because those are very small. And so, but if they show that, even though their numbers are going to be a little further off, as long as they show that, they can get full credit. But the easiest way to think about this is looking at the 2 bars where I'm going to be rejecting. All right.